Unit 10, Formative 1. Simplify, write each polynomial in standard form. So on number 1, there's a plus sign in between the two sets of parentheses, so that means we can just ignore the parentheses and add like terms. Remember, like terms are the same exponent raised to the same variable. So negative 8x to the third and 17x to the third are considered like terms. So that would be 9x to the third, and then 4x squared is the only x squared term, and then 9x is the only x term. So when it says to write it in standard form, that means we need to have the largest exponent first, and then the next largest exponent, and so on and so forth. So it just has to go in order. So that's it. That's your answer. For number 2, we have the quantity x minus 7 squared. So in order to expand that and multiply that out, we take the base, which is x minus 7, and we write it times itself. And then you could use the box method or FOIL from there. So I'm going to FOIL. F is first times first, so x times x is x squared. O stands for outside, so outside times outside is x times negative 7, which is negative 7x. I stands for inside, so inside times inside is negative 7 times x, which is negative 7x. And then L is last times last. So negative 7 times negative 7 is positive 49. And then we need to add our like terms in the middle. So x squared minus 14x plus 49. And number 3, we have that minus sign in between the two sets of parentheses. So we need to distribute the negative sign to everything in the parentheses in the back. In the front set of parentheses, I'm just going to drag everything down. So 5x to the third minus 8x plus 7, and then minus 6x to the third minus 5x squared plus 9. And then we're trying to find our like terms. So 5x to the third minus 6x to the third is negative 1x to the third. I typically don't put the 1 in front of the x to the third because it's more simplified to not have it. But if you had the 1 right here, it would be fine. I wouldn't count it wrong. And then let me switch colors. Do I see any x squared terms? Yes, I do. So minus 5x squared. Let me switch colors again. I'm looking for x's. So minus 8x. And then I think we're just left with our constants. So 7 plus 9 is 16. And there you go. That's your answer. On 4, there's no sign in between the two sets of parentheses. Same thing with 5. So those are both multiplication problems. So on number 4, it's every term in the first set of parentheses times every term in the second set of parentheses. So x times x squared is x to the third, because when you're multiplying like bases, you have to add the exponents. So invisible 1 plus 2 is 3. And then x times negative 7x is negative 7x squared. Again, there's an invisible 1 on the exponent for the x. And then we switch colors. X times 1 is simply x. Now I need to take the 2 times everything. So 2 times x squared is 2x squared. 2 times negative 7x is negative 14x. And 2 times 1 is 2. So we did every term in the first set of parentheses times every term in the second set of parentheses. Now we just need to look for any like terms. So x to the third is all by itself. Now I'm looking to see if I have any x squared terms. So there's 1 and there's 1. So negative 7x squared plus 2x squared would be negative 5x squared. You'll notice when we're adding like terms, we do not change the exponent on the variable. Then I'm looking for x's. So x minus 14x is negative 13x. And then at the end, I just have this constant 2 all by itself. So plus 2. So there is your answer. On number 5, I'm going to FOIL again. Actually, let's do the box method, mix it up. So I have x and 3x minus 9. So x times x is x squared. 3 times x is 3x. X times negative 9 is negative 9x. And negative 9 times 3 is negative 27. And then remember, you have to add those like terms. So then we get x squared minus 6x minus 27. On 6, we're practicing some exponent rules that we haven't done in a while. So on 6a, you're just multiplying. So the coefficients, the 2 and the 3, just get multiplied together like normal. So 2 times 3 is 6. X squared and x to the 5th, when you're multiplying like bases, you add the exponents. So 2 plus 5 is 7. And then for the y's, don't forget there's an invisible 1 on the y. So y times y to the 3rd is y to the 4th, because 1 plus 3 is 4. For part B, there is a lot going on here. We have some negative exponents that we can flip. We have some coefficients that we can multiply and divide. So let's do the 4. I'm going to zoom in for a second here. Let's do the 4 times 2 up top. So 4 times 2 is 8. And then I'm going to leave the x squared up top. The x to the negative 4 in the denominator, I'm going to flip that up to the top, because whenever you have a negative exponents, you can flip them and then change the sign of the exponent. Then, in the denominator, I'm going to leave the 4 where it was. And then you notice that y to the negative 3rd I skipped over in the numerator. I'm going to flip that down to the bottom and make it y to the positive 3. Because again, you can't have negative exponents in your final answer. So I'm going to flip all that around. At this point, the 8 divided by 4 in the front is a regular 2. The x squared times x to the 4th up top, I'm multiplying like bases, so I'm adding the exponents. So 2 plus 4 is 6. And then the y to the 3rd will just stay in the denominator, and then that should be it. That should be my answer. Let me double check and make sure I didn't skip anything. So 4 times 2 is 8. I flipped the y to the negative 3rd down. I flipped the x to the negative 4th up. And I think we got it all. Good. For 7, you're doing an evaluating a function type of problem. So basically you just take, let me switch colors here. For k of 12, I just take the k function. Wherever I see an x, I'm going to plug in a 12 like that. Remember, 12 is like 12 over 1. So when you do 1/3 times 12, you could just multiply across the top and multiply across the bottom like that to get 4. Or the other way to think about it, when you multiply something by 1/3, it's the same as dividing by 4. So k to the 12th is equal, or not k to the 12th, k of 12 is 4, just by plugging 12 in for x in the k function provided. For r of 3, I'm going to take a 3 and I'm going to plug it in for x in the r function. So then 3 squared is 9, so 10 minus 9 is 1. And at the very end here, I'm supposed to do k of 12 plus r of 3. So k of 12 was 4. R of 3 was 1. So then I just do 4 plus 1 is 5 for the final answer. With the matching of the definitions, so a coefficient should be choice B. It's the numerical or constant quantity that's placed before and gets multiplied with the variable in an algebraic expression. So that's gone. A term is choice E. It's a single number of variable or numbers and variables multiplied together. They're usually separated by a plus symbol or a minus symbol. For number 10, an exponent is a quantity representing the power to which a given number or expression is to be raised. So that's choice C. For 11, the degree of a term is the choice D. It's if one variable, it's just the exponent. With more than one variable, it's the sum of all the exponents on the variables. And then that last one, number 12, should be choice A. So degree of a polynomial is the highest degree of all the terms. In this next section, we're supposed to say what the degree of the polynomial is, as well as the type of polynomial. So remember, a monomial has one term, a binomial has two terms, trinomial has three terms, and then a polynomial is the generic name for any polynomial, so any number of terms. So basically, a monomial, binomial, and trinomial are all special types of polynomials. So we don't really have a special name for a four-termed polynomial or a fifth-termed polynomial. So this is just like any number of terms. In our cases, anything 4 or greater, we'll just call it polynomial. So on number 13, the largest exponent on the variable is a 2, making it a second degree. So I'm going to put a B in the first spot because it's a second degree. And then I see 1, 2, 3 terms, making it a trinomial. So I'm going to put G for trinomial. On number 14, largest exponent on a variable is a 3, making it a third degree polynomial. So that's choice C. And then I see 1, 2, 3 terms. So that would be a trinomial. Let me make that G actually look like a G. There we go. For 15, the degree, there's an invisible 1 on that x, so it's going to be a first degree polynomial, and I see 1, 2 terms. So it's going to be a binomial, which is choice F, because it has 2 terms. On 16, the exponent's a 3, so it's a third degree polynomial, and it has just the one term, so it's a monomial, so choice E. And then that last one, careful, the 4 is the largest exponent on a variable. So that polynomial was not written in standard form. So we had to kind of look at all the terms and find the largest exponent on a variable. So it's a fourth degree. And then since it has 1, 2, 3, 4 terms, we'll just call it a polynomial, choice H. 18, draw and label a picture that represents the situation below. Do not solve. So a 25-foot inflatable bunny is anchored to the ground with a 30-foot tension wire. What is the angle formed between the wire and the bunny? So this is an old spiral question. It's a trigonometry problem. So I'm going to draw my right triangle. The 25-foot bunny is going to be right here, vertically up and down. And then it's anchored to the ground with a 30-foot tension wire. So right here, this is my wire anchoring it to the ground. So 30 feet. And then it says, what is the angle formed between the wire and the bunny? So the wire was in red, the bunny's over on the left side in blue. So right here would be the angle formed between the wire and the bunny. And that is all.